My dear students, let me welcome you all to a new edition of physics. In this edition, we revised chapter 4. In this edition, you'll be encountered with miscellaneous questions, such as choose, give reason, explain, compare, and prove. So let's get started. Revision on chapter 4. We'll revise AC circuits. The first question to start with is choose. In RLC series circuits, resonance state occurs when XL equals XC, Z equals R, XL equals R, V total equals VR. RLC means circuit that contains an inductor, capacitor, and ohmic resistors. Resonance state, I can hear you saying, of course, XL is equal to XC, VL equals VC, Z equals R. Yes, V total equals VR. They are all correct, but XL is equal to R is wrong. So you have to choose one only. 1, 2, and 4 are correct. 3 only. Of course it is. Or 2 and 3. Yes, of course it is. 1, 2, 4 are correct. 1, which is XL is equal to XC. 2 is correct. Z becomes minimum in resonance state, and it is equal to ohmic resistor. V total is the voltage across the, yes, ohmic resistor. Okay. In the AC series circuit that contains an ohmic resistor R, an inductor whose reactance equals 4R. So XL equals 4R. XC equals 3R. Okay. The voltage leads the current by 45. The current and the voltage are in phase. The current leads the voltage by 90. The voltage lags behind the current by 45. Okay, how to do it? First of all, you need to know something here. XL equals 4R. Great. XC equals 3R. So XL is greater than, yes, XC. So we expect the voltage to lead the current by an angle. We need to calculate the angle. XL minus XC over R. 4R minus 3R, it is R. Over R, it will be 1. Okay, what about the angle in this case? Tan the angle which is equal to 1, it is 45. So the right choice is the voltage leads the current by 45. In the AC series circuit that contains ohmic resistor R, inductor L, capacitor C, the voltage across the capacitor VC equals the voltage across the inductor VL. And this happens only when we reach resonance state. And it is mentioned that each one of them is equal to 5. And total voltage or voltage across the resistor is equal to 2 volt. Let me say it again. In the AC series circuit that contains an ohmic resistor R, inductor L, capacitor C, voltage across the capacitor equals voltage across the inductor and is equal to 5. VR is equal to 2. Let me remind you with something. We are in resonance state. In resonance, VR is equal to V total. Okay. Choices. The circuit is in resonance state and total voltage equals 2 volt equals VR. This is 1. Voltage and current are in phase. Total potential difference across capacitor and inductor is 2. No, In this case, since VL is equal to VC, voltage across both of them should be 0. Resonant frequency is given from the expression 1 over 2 pi square root L over C. So the first is correct, second is correct, fourth is correct, but number 3 is incorrect. So all of them are correct. One only is correct. 1, 2, and 3 are correct. 1, 2, 4 are correct. Of course, 1, 2, and 4 are correct. Another choice. In an AC circuit that contains an inductor, the maximum current that flows through the inductor. So this choice asks about the relation between maximum current and frequency. In an AC circuit that contains an inductor, the maximum current that flows through the inductor is directly proportional to square the frequency of the current, is independent on the frequency of the current, directly proportional to the frequency of the current, inversely proportional to the frequency. The circuit contains inductor. Okay? In case of the inductor, the maximum current is independent on the frequency. So the right choice is number B. Another choice in an AC circuit that contains a capacitor, the maximum current that flows through the capacitor is maximum current that flows through the circuit of the capacitor is directly proportional to square the frequency of the current, independent on the frequency of the current, directly proportional to the frequency, inversely proportional. Okay, maximum current is calculated from V maximum which is NAB omega, NAB 2 pi f over XC. XC equals 1 over 2 pi FC. So we expect the current, maximum current, to be directly proportional to square the frequency. And now choose unit of square root L over C. Is it a second or 1 over second, second negative 1, ohm? Okay. Or is it volt? Of course, it is, yes, unit of resistance. And we'll prove this in this edition. Okay. Another choice. At very high frequencies, the circuit that contains an inductor is considered a closed circuit, considered as an open circuit, as the reactance of the coil is then a maximum, does not allow the passage of the alternating current because the ohmic resistance of the conducting wires increases. Okay, circuit contains an inductor. Inductive reactance is given by XL, which is equal to pi, yes, nu or FL, okay, to pi FL. So XL is directly proportional to the frequency. When increasing the frequency, we'll increase XL. XL is some sort of opposition. So the current, yes, dramatically decreased. So it is considered as an open circuit. And the reactance is then a maximum. Okay, thank you very much. The following figure is the vector diagram for an AC circuit that contains a pure inductor, capacitor, and ohmic resistor. Okay, so it is shown that the total voltage leads the current by an angle theta as it leads VR. VR is in phase with the current, so you can imagine it as current. So total voltage, okay, leads the current by an angle theta. First choice, phase angle between the voltage across the capacitor and that across the inductor is 180. Yes, as a matter of fact, this is always true. Phase angle between the voltage across the capacitor and that across the inductor is 180. Total voltage leads the current by an angle theta. Yes. Inductive reactance of the coil is less. No. Voltage leads the current, so inductive reactance is greater. Voltage across the capacitor leads the current by 90. Actually, it lags by 90. So the right choice, okay? 1 and 2 are correct. 1, 2, 3 are correct. 3 only is correct. 3 and 4 are correct. Of course, as I said, it is 1 and 2. Another choice, also we've got a figure here. The figure is the vector diagram for an AC circuit that contains pure inductor, capacitor, and ohmic resistor. In the diagram, we can see that VR coincides with V total, and this means we've got resonance state. Okay, we've reached resonance state because total voltage coincides with the current. Okay, so first statement, the circuit is at resonance. I've already mentioned this. Impedance of the circuit is a maximum. Okay, we're reaching resonance. Impedance is minimum, not a maximum. Okay, so second statement, once again, impedance of the circuit is a maximum at that frequency of the alternating current. Phase angle between voltage across the coil and current is 90. It is always true. Voltage across the capacitor leads the current by 90. No. So choices, 1 only correct. 1 and 3. 1, 2, 4 are correct. 1, 2, 3, and 4. Of course, it is 1 and 3. In the following circuit, the inductive reactance is greater than the capacitive reactance. Okay, inductive reactance is greater than capacitive reactance. We've got, yes, a voltage across the coil, we call it VL, across the capacitor VC. V1 is the voltage across both of them. Okay, and we've got VR. Total voltage is calculated from the expression square root VR squared plus VL minus VC all squared. Okay, I can hear you say this is a statement is true. V1, voltage across the capacitor and inductor, is calculated by the difference. Okay, and it is VL minus VC because XL is greater. I can hear you saying, yes, this is also true. VR is the current. You can replace it with the current. This will make it much easier for you. VR leads VC by 90. Okay. Phase angle between VL and VC is 90. As a matter of fact, I've just mentioned phase angle between, yes, VL and VC is 180. So choices 1, 2, 3 are correct. All are correct. 4 only is correct. No correct answer. Of course it is 1, 2, 3 are correct. Another choice, you're given some graphs. Which graph represents the relation between the inductive reactance of a coil and frequency of the AC current? Inductive reactance of a coil and frequency. Inductive reactance is directly proportional to the frequency. So is it A, B, C, D, or E? It is directly proportional, so it must be D, of course. Ohmic resistance and frequency, relation between ohmic resistance and frequency of the AC current. As a matter of fact, ohmic resistance, yes, is independent of the frequency. It depends on length, cross-sectional area, material, and temperature. It has nothing to do with the frequency, so it is independent. Choices A, B, C, D, E. Of course, it is independent, so it must be a horizontal graph. It is C. Impedance of RLC series circuit. Impedance and frequency. Okay, is it A, B, C, D, and E? Of course, it is B, of course. And what about the relation between capacitive reactance and frequency? A, B, C, D, and E. Capacitive reactance and frequency, we've got an inverse relation. So it must be A or B or C or D. It must be letter A. Another sort of questions, give reason for. At very high frequencies, the AC circuit that contains an inductive coil is considered an open circuit. Open circuit means no current flows. Okay, inductive reactance is given from the expression 2 pi FL. So XL is directly proportional to the frequency. So when the frequency increases, XL increases. XL is some sort of opposition. So current is sharply decreased. At very high frequency, inductive reactance increases and current is decreased. Okay, another give reason. At very high frequencies, the AC circuit that contains a capacitor is considered a closed circuit. XC is given from the expression 1 over 2 pi FC. So XC is inversely proportional to the frequency. So the capacitive reactance decreases when the frequency is increased and high current flows in the circuit. Another give reason. In resonant circuits, the current and the voltage are in phase. At resonance, what happens? XL equals XC, VL equals VC, V equals total voltage equals voltage across the ohmic resistor, V total equals VR. Impedance is a minimum and is equal to R, Z equals R. V and I are in phase. That's to say phase angle is equal to 0. Theta equals 0. Okay. Give reason. Capacitors do not allow the passage of the direct current. By the way, direct current has 0 frequency. The question again, capacitors do not allow the passage of the direct current. XC capacitive reactance equals 1 over 2 pi Fc. So XC is inversely proportional to the frequency. So at zero frequency, direct current has zero frequency, as I said. So the capacitive reactance is infinite, very high, and no current flows. Another give reason in DC circuits that contain inductive coil. DC circuit means circuits powered by a battery. In DC circuits that contain inductive coil, the inductive reactance is 0. XL equals 2 pi FL. So inductive reactance is directly proportional to the frequency. Direct current has 0 frequency, so the inductive reactance is then 0. In AC circuits, the ohmic resistance has only one value, but the reactance has infinite values. In an AC circuit, the ohmic, or in AC circuits, the ohmic resistance has only one value, but the reactance has infinite values. Ohmic resistance does not depend on the frequency of the supply, but reactance depends on the frequency. XC equals 1 over 2 pi Fc, so it is inversely proportional to the frequency. XL equals 2 pi FL, so it is directly proportional to the frequency, but ohmic resistance is independent of the frequency. Another give reason, the average consumed power during one cycle in a pure inductor connected to an AC supply is 0. Let me say it again. The average consumed power during one cycle in a pure inductor connected to an AC supply is 0. Yes, in pure inductors, the electric energy is not converted into thermal energy, but stored in the form of magnetic field. On the first quarter of the current, the energy is stored in the form of the magnetic field of the coil, and on the next, the energy is returned to the generator, and so on. The pure inductor just makes the voltage leads, yes, on the current by 90. Another give reason, the average consumed power during one cycle in a capacitor connected to an AC supply is 0. As a matter of fact, in pure capacitors, the electric energy is not converted into thermal energy, but is stored in the form of an electric field. On the first quarter of the current, the energy is stored in the form of an electric field on the two plates of the capacitor, and on the next quarter, the capacitor discharges, and so on. The pure capacitor just causes the current to lead on the voltage, or causes the voltage to lag behind the current by 90. When does each of the following quantities equal 0? Reactance of a pure inductor. When does a reactant of a pure inductor equal 0? Of course, in DC circuits, when the frequency, or where the frequency is 0. When does reactance of a pure capacitor is 0? Thank you very much. In an AC circuits with very high current frequency. When does total reactance of an AC circuit that contains pure capacitor and pure inductor equals 0, when the inductive reactance equals the capacitive reactance. And now we've got another type of questions. Prove that the unit of the capacitive reactance XC is ohm. Prove that the unit of the capacitive reactance XC is ohm. Okay, frequency is the reciprocal of the periodic time. And yes, C equals Q over V. Capacitance equals Q over V. XC, since XC equals 1 over 2 pi FC, so XC equals 1 over, yes, 2 pi, and instead of F, we say 1 over T, 1 over periodic time, C equals Q over V. Okay, so voltage over Coulomb over second. So voltage over Coulomb over second. And what about Coulomb over second? It is ampere. So voltage over ampere, which is ohm. Prove that the unit of square root L over C is ohm. L is given from the expression EMF delta T over delta I. So unit of L equals volt second over ampere. Volt over ampere equals ohm, so it is ohm second. Since C equals Q over V, so unit of C equals Coulomb over volt, and Coulomb equals ampere second, so unit of C equals ampere second over volt. Okay, so volt over ampere equals ohm, so unit of C equals second over ohm. And now we can obtain unit of square root L over C. It is square root ohm second over ohm. Second will be crossed out, so square root ohm squared, which is ohm.